Okay. Good afternoon to everybody. I came to Paris, to IIS, in 2004 for a postdoc with Alan, just after my PhD, and just after the publication in 2003 of the two works on Plume and Interplume subject that we have seen before. So it started in a very exciting work with Alan, which is still in progress for some items that we will see later. So about the Plume and Interplume, we published in 2005 this work that I'm going to show you. So there were two publications in 2003 with apparent contradiction in the results. So the work from Luca and co-authors analyzing SUMER and UVCS data, obtaining an outflow only for the Interplume regions and a static regime for the Plume. And in the work of Alan of 2003 and co-authors, they found a different situation, a different ratio of the oxygen 6 lines, and a different velocity results with the Plume not static in the low corona, and Interplume with the lower velocity in this part of the corona. So when I started to work with Alan, first of all, we tried to identify the path of the Plume and Interplume regions, including SUMER, UVCS, and EIT, and LASCO observations. Because just to take the brightest and the darkest path in intensity, maybe it's misleading. I mean, there is the Doppler dimming on oxygen 6 lines, and Doppler dimming can become effective and reduce the intensity of plumes with increased velocity, thereby reducing their contrast and visibility. So we identify the plume paths also using the LASCO C2 data, because LASCO responds to density and not to the velocity. And then we considered also the EIT data, because the image of EIT has a much lower Doppler dimming effect than oxygen 6. So here you can see the data set, the entire data set for the 2005 paper with EIT, UVCS, SUMER is here, it's not shown, but we consider it, of course, and LASCO C2. And we trace the path for Plume and Interplume region, not just following the brightest and the darkest paths. The results, very briefly, because I have the second part of the presentation as well. So we found that the UV polar plumes do initially exhibit a higher velocity than the Interplume region. The acceleration is smaller for the plumes, so their velocity is overtaken by the Interplume material around 1.6 solar radii. It's shown here. There is the overtaken for the Interplume velocity. And this result explained the apparent discrepancy between the two publications of 2003, but not everybody is convinced on that. So we had the EC team, as already explained by Klaus and Luca. And in the paper of 70 pages, you can read all the story, the entire story of that. And then I have a second part. Yeah. Thank you. Okay. And then we change the subject, because in November 2007, I went to IAS for the INODE workshop, and at that time, Alan proposed to me to start a new study on the supragranular network for understanding the origin of the fast wind with the INODE data, so new data. It was very stimulating for me to change spectral lines and temperature range because my background was about UVCS data and the outer corona, discovering the transition region structures. We had and still have a lot of problems in analyzing data due to very low signals in coronal holes, regions observed with ice data, and also due to the pointing, some changes between the planning and the observations. And we are looking for equatorial coronal holes observations and very good quiet sun regions. Anyway, as usual, we have problems. And we decided to divide the analysis of the network boundary of the supragranular cells as a function of temperature in two parts: the study of the outflow velocity and the analysis of the network boundary width. So very briefly, the study about the outflow velocity at the boundary of the supragranular cells, it's shown here. It's already published 1 year ago. So we divided the observation of ice in two parts. We identify a coronal hole and a quiet sun region. And then for identifying the network of the supragranular cells, we used the SDO data, mainly the AIA continuum data, 1,600 Armstrong. And to check this observation, we used also HMI Dopplergram and magnetic field structures. So we trace the boundaries of the cells, and we superposed these patterns on the Dopplergrams from ice data that you can see here for 3 lines, iron 8, iron 10, and iron 12. So we can go through from the transition region up to the corona. And the green and blue colors are 2 different thresholds for blue shifts, are both blue shifts. And you can see the differences in these 3 lines. For the transition region line, we see blue shifts along the pattern of the cells and also in the intersections of the cells. When we go to the real corona line, we see a spread of the blue shift in very big regions. And also here you see the histograms of the dispersion of the velocity. Of the velocity in these 3 lines. And you can see there is a narrower dispersion of the pixels as a function of temperature from iron 8 to iron 12. This suggests that there is a stochastic release of energy due to magnetic reconnection, likely, in the low transition region, okay? Because here the spread of the distribution is wider than in the corona. This is a work in progress. These are the last plots that Alan sent to me 10 days ago. So maybe Alan can explain better than me these plots. Anyway, we are, the work is in progress. We enlarge the temperature range from log T equals to 4.7 to 6.3 to have a wider range in the solar atmosphere. We separate better the results from regions of quiet sun and coronal hole, and we obtain an absolute scale for the outflow velocities. This is almost done, but we have to fix all the ideas. Yes, okay. The second part of the work is concerning the network boundary width as a function of temperature. And we divided the 2 regions, the quiet sun and coronal hole regions. And with the technique of autocorrelation of monochromatic images, we studied the minimum scales in in the monochromatic images of ice and CDS, and we found a difference in the width of the supragranular cells in coronal hole and quiet sun, as you can see here in this plot, comparing with the Patsurakos et al. 1999 results. There are theoretical support for the difference in the width of the boundary between these two regions. I don't go into the details. And now I want to finish with some pictures, nice pictures with several visits of Alan to Torino with the intercultural moment. He went several times, once in 2008, and we had a dinner at the observatory with the pasta ai frutti di mare. And then I remember another visit in October 2009 for the École Challenge with election on solar atmosphere as a driver for the corona. This is a slide from his presentation explaining his idea about the two kinds of polar plumes. And here there is also a nice movie explaining the idea of the curtains or network plumes with this alignment of a lot of small structures. And after the colloquium, after the École Challenge, we had a lesson of wine of Barolo, and also a lesson of dance at Planetarium. I don't have a picture explaining that, but we remember very well his performance. It's clear in our memories. And last but not least, Alan and Christine went to my special day of last year, bringing his car to Liguria, to Italy, by means of a train. I don't know if it's correct in English, but with a very long and adventurous trip. So thank you very much for the passion in physics, for the enthusiastic and the young attitude in research that you teach me.